Nice. Right, so we're going to refresh our memories on quadratics. Right? We're not going to get into the high level stuff. We're really just going to make sure that you guys know how to expand brackets along with a few shortcuts such as perfect squares and difference of perfect squares. Alright, which are two things that you need to know off the top of your head when you see one. So, 18, 02, 20.
Oh, it's expanded.
Expand. It's relatively straightforward, Taylor. So, point one. Perfect. Squares, point two. Difference. Dots. Whatever you want to call it. Right. So, few examples. Everyone should be familiar with something like this. Yeah? How do you expand the brackets?
Times everything by 3.
Yeah, so if you want to be visual, you do this. And you have 3 times x plus 3 times 2, which is 3x plus 6.
Get it.
Yeah?
Yeah.
The lines are very helpful. They may be too simple in this case, but in later cases they actually get a lot more helpful. Alright? Is that surprising to anyone? Did anyone not know that?
No.
No? No questions about where the multiplying sign comes from? No? Good? Yeah. It suddenly appeared here.
Oh, yeah.
Yeah? Alright, that good?
Yep.
Excellent. Alright, moving on. Does everyone know how to do this type of example?
Yep.
Yeah.
Yep.
Foil. Yes.
Alright,
Times
foil.
everything by-
I've deliberately not written it on the board because I don't really like it, because when we get to higher levels of methods, foil goes out the window.
Oh.
Really?
Because it doesn't cater for examples like this.
Oh, no.
Oh, really?
What?
Oh,
That's a thing.
Yeah, that's a thing.
We did that last year.
But you just do
So-
the thing. It's like
We'll get to that in a second. Alright, so, Uli.
Can I do the
Yeah, go. Thought it was going to be a maths question. Alright, so what do I do in this situation here?
The first
Yep,
and the opposite,
yep,
inside, and the last.
yep. Again, the arrows are very helpful. Right? If you're not in the habit of drawing them, you might want to. So x times x is x squared, 5 times x is 5x, 2 times x is 2x, and 2 times 5 is 10. What do I do now? Good use of terminology. Collect like terms. Alright, so x squared doesn't have a like term, 5x and 2x become 7x, and 10 doesn't have a like term, and you have a quadratic. Yeah.
Oh, no, don't worry.
Don't worry.
I was going to say factorise it, but...
Yeah, don't worry, we'll just go expanding today. That will be the next step, that we could go back to the factors. Right, who knows why it's called a quadratic?
It generally deals with something about 4.
Well,
Nope.
square?
It's about
2
Square.
squares. Yeah.
It's linked to the power. The highest power is a 2. Therefore it's a quadratic.
what if it was a 3?
It'd be a cubic.
It'd be a what, sorry?
A cubic.
It's the power of like a billion.
I don't know the name of that one. Just a higher power. In year 12 methods it goes quadratics, cubics, quartics, and then they go higher powers.
So higher powers is just anything else.
Basically, yeah. And once you go through quadratics, cubics, and quartics, you see a pattern. And then you notice what happens to every power after that. It'll be one of 2 different shapes. Alright, so there's not really
What
any
are the
need
2
to go.
different shapes?
Square or rectangle.
Squiggle.
Alright, well, what shape does a quadratic make?
Is it a circle or a square?
Squiggle.
Quadratic. Like this?
Yeah.
Yeah.
And the other
We
one.
notice that it starts and stops and begins and ends in the same direction.
Or a hyperbola.
What shape does a cubic make? Does anyone know?
Yeah, it goes like.
Yep, so it goes like this.
That was 5.
Alright, if we place the windows.
Pardon?
Place the windows.
Yeah,
So, when you get to higher powers,
It looks like with them, like the
a quartic and anything with even powers. So if your highest power is an even number, it looks like this. If your highest power is an odd number, it looks like this.
Should I write that down?
No, that's for you 12. You just wanted to know.
Uh-huh.
It still looks like, okay. Well, yeah.
All good. Right, so this you've known as FOIL, haven't you?
Yes.
And Will went through the first outside, inside, last. I think Will called it opposite. Yep. So terms opposite each other at the either end. Generally, I teach it as
Outside.
outside.
First outside.
All right. It's there to help you when you have 2 sets of brackets, which is the most common thing. But what would happen if you had 3 sets of
We
brackets?
give up on life.
Yeah, basically. Curl into a corner and just give up.
So why are you using that?
So what would you do?
Try.
Yeah.
Would you expand the first 2 brackets and then?
Yeah, it's not difficult. You just do
My bike's gonna get
these 2
wet.
brackets.
We should probably do it.
Nah, we've got massive eaves. And you do x squared minus 3x plus 4x minus 12. And you haven't done this bracket yet.
Wait a second. So you got X squared.
You can write it down later. That's not good.
Oh.
And then you would gather your like terms and you end up with this. And then you notice something wrong.
Wait,
Ben,
So-
shut up.
X squared is x times x, minus 3x is that times that, 4x is that times that, and minus 12 is that times
so does
that.
it become, oh, it's plus X.
Yep.
Plus X.
Right?
They got the
And this is where, Aaron, your FOIL falls down because you go first, outsides will be those, insides will be those, and last would be those 2, but you've missed that x term in the middle.
Well, it can go to hell.
So this is where you go back to something like Lockie and just remember that FOIL stat, it just is the idea of
Multiplying everything by.
everything times everything.
So you times everything by?
Alright, so erase these blue lines
Oh, why would you do that?
and redraw them so that it goes, the x squared has to be multiplied by that and that. The x has to be multiplied by that and that. The 12 has to be multiplied by that and that.
Right.
And you've got 6 multiplications there. Everything times everything. Does that make sense?